Hi everyone, my name is William Hurst and I'm a Manufacturing Engineering Manager with L3 Harris Technologies in Virginia. In today's Tribe Talk, we're going to look at the solid rocket motor industry, and in particular, we're going to focus on how the solid rocket motor industry is facing critical challenges in meeting and adapting to modern warfare needs. We'll examine the current situation, the impacts, and a potential solution for industry transformation. So what are solid rocket motors, or SRMs? First off, they are solid fuel propulsion or gas generator devices that are used for thrust in many different weapon systems. They're used in smaller man-portable systems such as the Stinger or the Javelin, which are more defense systems. They're also used for maneuvering on ICBMs, intercontinental ballistic missiles, which are much larger. Why do we use solid fuel systems? First off, they are very efficient. They have few structural components, so a majority of their weight is in propellant itself, and so that gives them a very high thrust ratio and longer range for a relatively low cost. They're also very reliable. They can be stored for a long period of time without any degradation in the propellant, or minimal degradation when compared to liquid fuel systems, and that makes them very dependable. They're also very flexible. The propellant contains both fuel and oxidizers, so they can operate within the atmosphere or outside the atmosphere or across both during their mission. My wicked problem is looking at inflexibility in the production of those solid rocket motors. Russia's invasion of Ukraine has revealed how critical advanced missiles have become on the modern battlefield. And that's where you have much smaller, much cheaper, portable, high-precision systems that are offsetting much more expensive, much larger threats like the latest tanks and armored vehicles. That situation, though, has rapidly drained the global supply of those systems. You can see a picture here of Javelin. That's been one of the major players in Ukraine. And the current production in the United States is unable to facilitate rapid replacement, whether it's to backfill weapon systems or to meet the surge in demand that we're seeing right now. Foreign military demand is also increasing rapidly. Many of the countries in Europe are realizing that conventional war on that continent is no longer inconceivable like they thought for many years. So they're now looking to backfill the equipment they sent to Ukraine and then also to source new advanced systems so that they can be ready for any future conflict. So why is the industry in this current situation? A lot of it stems from government policy controls, where the government's controlling the funding or export policy or production requirements for many of the systems. And a lot of those policies have been around for decades, really since the Cold War. Funding and direction in terms of DoD procurement has also changed from administration to administration. So with those changes, it's become difficult to have any sort of sustained improvement when it comes to a very expensive, or when it comes to an infrastructure that's extremely expensive to upgrade and to maintain just at that. So when we have changes in the administration or changes in how much the DoD is going to purchase or how they're going to do things, the companies are much more likely to keep things the way they are and not introduce innovation or change or flexibility into the system. So first off, we have the demand or change in demand across the globe that was sparked by Russia's invasion of Ukraine, really showing the performance of these systems and how essential they are. We have inadequate capacity in the current production processes, and that's just for meeting the current demand changes. And it highlights an insufficiency to meet any sort of near-peer adversary conflict demand change. So if we were to go to war with China, it'd be very difficult to provide enough of these systems, which will be essential. Government policy challenges where the unclear funding and direction have hindered a flexible industrial base. Also, the contracting policies where production contracts are locked in place. It is considered a no change policy for how we do things. If we want to make a change in how we produce a product, there are many levels through which we have to go when it comes to change management. And a significant amount of data is required to go and prove that any change is as good or maybe even better than the existing process itself. So those policies have hamstrung any sort of innovation efforts within the industry. And then we have the production limitations that are associated with the production equipment themselves. It is a highly batch process where propellant is mixed in a mixer. It is then cast, cured, and then detooled and then installed into whichever device that it might go into. And because of that, trying to scale that operation can be very difficult. And many of the production lines are dedicated to one specific product, and that's where they're used. When there's no demand for that product, they might sit idle because they're not as flexible as they need to be. The equipment used in the manufacturing of solid rocket motors is very expensive. A lot of it's from the 1960s or 70s, and therefore the industry really is a latecomer to digital transformation. Industry constraints and challenges. We have the procurement policy that I talked about that is really constrained production innovation. That stems from a lack of vision coming from on the part of the government or also from the companies themselves. Traditionally, we've only had two suppliers of solid rocket motors in the recent past in the United States. That's due to industry consolidation. We have Aerojet Rocketdyne, which was just purchased by L3Harris, and then we have Orbital ATK, which was purchased by Northrop Grumman. And because there was so little competition within the market, it was easy for those companies to just do things the way they've always done them and not introduce any sort of innovation in how they produce things or try to drive any sort of efficiencies. We have the aging infrastructure that I mentioned. That's where production technologies have not changed. They've remained the same really since the 60s or 70s when it comes to how we mix things. Maybe formulations have changed, but still the process through which things are done and the equipment it's done on, that has not changed. And many of the processes are still rooted in paper planning documents where technicians are filling out paperwork as it goes through the production process. That hasn't changed since the 1980s, for example, on Stinger. So certainly lots of room for change and improvement there. When we have a highly manual process with technicians on a very complex product, by the way, different technicians will have different techniques on how things are done. We see variation in the product. We don't have the data capture in place to be able to detect if a nonconformance will occur. We generally detect those after the fact. And so with the variation in the process and the lack of data capture, we see a very high cost of poor quality. So there are definitely opportunities there as well. With the limited manufacturing capacity, so expanded production is hampered by contract and capacity limits. So the infrastructure itself, but also contractually, it's very difficult to make any changes. To drive change into the supply chain, the U.S. Department of Defense released its first supply chain strategy in January of this year. With that, they're adding a lot of funding for investment into new innovation, flexibility, and agility in existing suppliers across the board for all defense systems, but also in the solid rocket motor industry. They're also funding a number of startups to come up with new technology for producing things in a more efficient or flexible manner. Current market dynamics, I mentioned how there are two suppliers of the solid rocket motors traditionally in the United States. We are seeing significant new competition coming into the industry. That's because the demand has changed so rapidly with the war in Ukraine and with the demand in foreign military sales. Lockheed Martin and General Dynamics have teamed up to form another solid rocket motor company. There are also several venture capital-backed startups that are pushing for better production technologies or just different production technologies. And they're not hampered by old infrastructure. And so they're able to be much more innovative when they come up with what solutions they're going to field for production. Challenges for the legacy producers, we have difficulty in meeting the current propulsion system demand. And so clearly unable to meet any sort of demand surge in the future, whether if we had a near-peer adversary conflict or something like that. That demand volatility is putting contracts at risk due to the limited capacity. We're already maxed at capacity. We're unable to bid on future contracts, and that's a threat to the company. Historically, within the industry, in terms of forces and factors, we had that supply consolidation that I talked about, fewer producers in the industry due to mergers and buyouts. We also have the financial uncertainty that I mentioned from the government. So it's when we're not getting consistent government commitment in terms of funding, it's difficult to make infrastructure changes or decisions when it's very expensive. We have that limited surge capacity that we talked about, and it's difficult to manage production increases very easily without any significant cost or significant investment. And because of all of this, we have a culture that's highly resistant to change, where it's a no change policy. That people want to see a significant amount of data before they agree to even investigate any sort of change within the current production processes. So a potential solution is a comprehensive digital transformation. We're looking at marrying the IT efforts of the solid rocket motor manufacturing producers, or really L3Harris Technologies, and when it comes to making IT decisions on where we're going to focus our digital transformation, those decisions need to be married to the goals of the company and the policies of the company. Like what's our real mission in terms of production? And so trying to marry those two together and sourcing the right solutions to drive flexibility and agility into the supply chain. First off, production infrastructure. So investing in automated, flexible production equipment that enables rapid retooling and also drives higher quality. So with an automated system, we can have more precise control over the process, and we can have faster data capture. So we can reduce the cost of poor quality associated with production, which should bring down costs overall. There's also fewer personnel required to run the automation, or you can just keep the automation running for longer periods of time when there is a surge in demand. And so that allows that flexibility. Also looking at digital solutions in terms of supply chain management. So identifying alternate sources or alternate suppliers, but also enhancing that connectivity between the stakeholders with the revised supply chain applications, coming up with the right solutions that allow us to communicate our changes in demand more rapidly to our suppliers and enabling them to respond more quickly to what we need. And then overall, redefining the industry culture. So fostering a culture of innovation and flexibility will be essential when we bring on board these new technologies so that people can focus on building out systems that are flexible and they are agile from the start, as opposed to simply building what exactly is required for that process and just planning to rebuild it completely for future products. The benefits of automation, we have, there are many benefits. We have, first and foremost, enhanced quality and safety. We can remove the person from the process, especially when we're processing explosives and propellant. So that's a good thing. Enhanced quality can help reduce the cost of poor quality and potentially enable faster flow through the system. We have the improved data capture, again, which is if we can predict that a nonconformance might happen, we can prevent it or engineer that out. And so that can significantly reduce costs. It adds line flexibility. An automated line can be retooled more quickly if flexibility is designed in from the start, and machines can be reprogrammed, and we retrain technicians so they can operate those machines and easily transition from one product to another. And we then also have scalable operations. So as we come up with the automated solutions that work and are reliable, we can easily scale those solutions much more rapidly since they're relatively off-the-shelf solutions. We go and just build more of what it is we already have. For an example, and these are just fictitious numbers, but as an example, if we're automating a propellant casting system that may cost approximately $2 million, that's in the ballpark of what would make sense if we were to try to automate just a propellant mix and cast station. Average cost of Javelin, for example, that missile system is assumed to be about $80,000. If you do a quick internet search, with about, we'll say a quarter of that is to the propulsion system, $20,000. Now, assume the cost of poor quality can attribute to an average of 10% of the unit cost. We'll say that's about $2,000 per unit. We do have a very high cost of poor quality. And assume 25% reduction if we added just the automation piece itself. We're not talking overhead or the reduction in manpower needed to run the system, just a 25% reduction in cost of poor quality only. That'd be $500 times approximately 4,000 units a year, which is a currently advertised production number of Javelin. That's a $2 million savings. That would pay for the automated equipment already. And that doesn't even speak to future automated processes, or that mixer itself will be used on other programs at the same time. You're not mixing continuously. So ROI just on that program alone will be in 1 year of production. So implementation strategy, how do we do this? It takes a lot of money up front, and luckily we have the government now that's stepping in to provide the resources to make a lot of these changes. First, we have to prioritize digital transformation. We're going to place IT professionals in leadership positions to marry IT decisions with corporate decisions. That's going to be essential, that our decision making when it comes to what applications or infrastructure we source has to be perfectly aligned with the goals of the company itself. We then need to invest in the infrastructure, update and automate machinery used in solid rocket motor production, and then standardize that across all sites. Ensure consistency. That should help with availability of spares and also build our internal knowledge of those systems so they'll be more maintainable, more scalable, and more reliable. And then we foster partnerships. So we engage with industrial automation suppliers and customers for knowledge sharing. As we learn more, we share that information so we can all get better, especially with suppliers. In conclusion, embracing change for future success. So we see a market evolution where demand is significantly changing in the solid rocket motor industry, and it's evolving to meet warfighter needs. We need a digital transformation, a comprehensive realignment to build efficiency and flexibility into the industry itself. We need to use an automation focus to maximize and drive flexibility and quality into those processes themselves, and then really focus on a cultural shift that focuses on innovation, agility, and flexibility. And when we design new processes, it must be based on those factors. Thanks.